Hello friends! This is the first video on my new channel Anti-Aging for Everyone, where I will be sharing with you science-based but practical information on how to stay young longer and live longer. I will be also sharing with you my personal experience with my anti-aging tactics and strategies. To those of you who don't know me, my name is Elena Kazareva. And to those of you who know me, or read my website on anti-aging, or follow me on social media, hello again. If there are any topics on anti-aging that you would like me to cover in the subsequent videos, share them in the comments. If you don't want to miss upcoming videos, subscribe to the channel. Before we dive into practical anti-aging tactics and strategies, I decided to dedicate the first two videos to providing you with the foundational knowledge and fundamentals on what exactly aging is and why we age. Then to two opposite points of view on aging and how all that translates to anti-aging. That framework will help you make better use out of the practical information on anti-aging that I will be sharing later. It will also help you better understand and evaluate claims on the effectiveness of anti-aging products, services, and strategies. To give more detail, in this first video, we'll go through what exactly aging is, not just on the surface, but behind the scenes, according to the latest scientific knowledge. We'll look at how the structure and functions of the human body are maintained when we are young and what happens when we age, causes and traits of youth and causes and traits of aging. And that will explain why we age. And obviously it will be a very high-level information. In the second video, we'll reconcile two opposite points of view on aging. One point of view is that aging and death are natural, and all we can really do is lead a healthy lifestyle. On the other end of the spectrum, the point of view is that aging is a disease, and as a disease, it could be and should be treated and possibly cured. Which point of view do you think is correct? And as we go through those two areas in the two videos, I'll be mapping some of the anti-aging interventions into that framework. Let's now proceed to the topic of this first video. What is aging and why do we age? When asked about aging, what are the first things that come to your mind? Typically, aging is associated with phenotypical, observable changes such as gray hair, facial wrinkles, stooped posture. Also, phenotypical decline in function, such as muscle weakness, cognitive decline, and finally, age-associated disease such as neurodegenerative disease and increased incidence of cancer, coronary heart disease, etc. That's what's observable. But what is actually happening inside our bodies behind the scenes? To explain that, we'll go through three areas, starting with the composition or the structural levels of the human body and how youth is maintained at all of those levels. Because the proper place to start examining aging is to start with non-aging, causes and traits of youth and health. And the third area in this logical chain is causes of aging that undermine causes of youth and health. Beginning with the composition of our bodies, molecules, water obviously, but also the major building blocks, proteins, also DNA and RNA, lipids, carbohydrates. Next level up, organelles. Organelles are compartments made of molecules and containing molecules and processes. An example of an organelle is a nucleus with DNA inside it, and DNA-related processes such as transcription of DNA to RNA. Another example of an organelle is a mitochondrion. Mitochondria are best known for one of their functions, production of the cellular energy in the form of ATP. Next level up, cells. There are about 200 types of cells in our bodies, and they're also made of molecules, and they house molecules, organelles, and processes. Then, supracellular units, for example, blood-brain barrier, structured to keep out of the brain dangerous or potentially disrupting substances. Also, extracellular environment with its extracellular matrix. Then, organs and organ systems, for example, endocrine or respiratory, and finally, systemic interactions such as metabolic or neuroendocrine. Let's recap. Molecules, organelles, cells, supracellular units, and extracellular, organs, 11 organ systems, and systemic interactions. And at each of those levels, our organisms have processes and backup processes to keep our bodies healthy and useful. A multitude of microscopic issues arise all the time at all the structural levels, just as a part of normal metabolism. That means that even in the perfect environment with the perfect lifestyle, an organism should still be able to perform a 24/7 quality control and repair problems of endogenous internal origin. And external too, because we don't live in the perfect environment. Even though our genes do not code for a regrowth of a new limb should we lose one, we are born with breathtakingly sophisticated mechanisms of, putting it in simple words, detecting and correcting problems. We are young and healthy, not just because we happen to be young and healthy, and not just because we are chronologically young, but because there are active processes, checks and balances that are performed by the body all the time to preserve the state of youth and health. And that's what I'm calling causes and traits of youth and health. Let's name those causes and traits of youth and look at some examples. Those causes and traits of youth are damage detection and repair or removal, depending on what it is and how badly it is damaged. Ability to adapt and withstand external stress, such as trauma or a toxic substance or a pathogen or a change in the environmental conditions. Ability to handle endogenous perturbations and maintain homeostasis. Recycling and regeneration, maintaining integrity of membranes and other barriers. Let's look at 3 examples of the mechanisms and causes of youth and health. A process that many people are now familiar with is autophagy, degradation and recycling of molecules and organelles, the process that's critically important for our health. Macroautophagy happens at the organelle level, and we'll pick a mitochondrion for our example. If and when a mitochondrion within a cell becomes damaged, it should be marked by the self-degradation, and the process is activated called mitophagy, which is a type of selective macroautophagy. During that process, a lysosome, another organelle, digests the damaged mitochondrion, and its building blocks can be later reused. And at the same time, the cell activates an additional process called mitochondrial biogenesis, which is building a new mitochondrion. Let's now look at an example of the causes and mechanisms of use at the very bottom structural level, molecular. I don't think it's a common knowledge that DNA damage occurs on a daily basis just as a part of normal metabolism, and that even vital molecules in our body can cause DNA damage. For example, even water, and we are not talking about polluted water, we are talking about H2O molecule, can damage DNA, which in this case is called depurination or deamination. In fact, tens of thousands of DNA changes or lesions occur in every human cell every day, except for the cells that don't have DNA, for example, red blood cells. And if a DNA base is damaged, enzymes will more often than not detect the problem and repair the damage. We have already looked at the organelle level, so we are going to skip organelles and scale further up to the cellular level. This will be the third example of the detection, recycling, and regeneration, which are listed as the causes of use and health. If a cell becomes damaged to the extent the damage cannot be repaired, that cell should be removed. In reality, this is a complex set of processes, but if we are to simplify, in a young adult, typically, if a cell is damaged by severe stress, it will normally undergo apoptosis, a suicide for the greater good of the surrounding cells and tissues. Or, under less severe stress, that cell will transition to the state of acute senescence and will be removed by immune cells. When that happens, the loss of that cell is compensated by either cell division or by a stem cell. Those are just three high-level, out of thousands, almost impeccably designed, if you will, mechanisms encoded by our genes to keep our bodies young and healthy. And they take place every day, just as you listen to this video. To summarize, our health and youth are actively maintained by a multitude of processes. As we age, those processes are becoming less effective, leading to the accumulation of damaged, dysfunctional components, impaired function, further leading to the observable signs of aging and vulnerability to death. And why does the above happen? Why are those processes becoming less effective? That is because the first group of processes, causes, and traits of youth and health are becoming gradually undermined by the second group of processes, causes, and traits of aging. We can call them causes and hallmarks of aging. And keep in mind that in this video, we are not even touching the dimension of the lifestyle and environmental factors. It's important to note that even among scientists who study mechanisms of aging and search for anti-aging interventions, there is no full consensus on the causes of aging or reasons for aging. There is, however, a more or less widely accepted point of view on the reasons for aging. And that point of view comes from a landmark 2013 paper in the Cell journal. The paper is called Hallmarks of Aging. In that paper, authors analyzed and summarized, classified and linked known causes of mammalian aging. Our goal today is to get an idea of the entire aging process, therefore we'll go through the hallmarks of aging succinctly. I have covered some of the reasons for aging quite extensively on my website, Anti-Aging for Everyone. The paper suggests 9 molecular and cellular pathways leading to aging, and they are classified or broken down into 3 categories: primary, antagonistic, and integrative. The primary reasons for aging are always negative, and also likely they are the ones that are triggering the entire aging cascade. The antagonistic group includes reasons that are intensity dependent. They are good and beneficial up to a certain level, but they are becoming deleterious at high levels. The third group is integrative reasons for aging, and we can say that they are down the hill recipients of what has been initiated or aggravated by the first two groups, and they are also the ones that actually lead to the dysfunction and aging of an organism. So let's look at those reasons. The first primary reason for aging is genomic or genetic instability. That is the increased tendency for DNA mutations and other genetic changes and accumulation of those mutations. It happens even if we lead a healthy lifestyle. But if you want to at least not aggravate it, minimize your exposure to mutagens, for example, pesticides, alcohol, fragrances. Also, make sure that you get sufficient sleep because DNA damage repair happens mostly when we sleep. The second primary reason for aging is epigenetic alterations. We have coding DNA or genome that contains complete sets of instructions on what can be possibly built by an organism. The epigenome is a multitude of chemical compounds that are attached on top of the coding DNA, from Greek epi, above. And those compounds can tell the genome what to do. They can tell which genes to express and which genes to suppress. Epigenetic alterations is a modification in the patterns of those chemical compounds. Age-related epigenetic alterations lead to suppression of good genes and to the expression of unwanted ones. The third primary reason for aging is telomere shortening or telomere attrition. Short telomeres lead to cell senescence and also impact gene expression. If you heard of TA65 or its genetic cousin cycloestrogenol, they are supposed to help with telomere shortening. And the fourth primary reason for aging is the loss of proteostasis. The body loses its ability to maintain functional and properly balanced proteins. And proteins are the major building blocks and the workers in our bodies. Moving further to the three antagonistic reasons for aging, recall that whether they are harmful or beneficial depends on their intensity. The first antagonistic reason for aging is cellular senescence. Cellular senescence is a protection against cancer. However, it is harmful at a high level. If you've heard of senolytics, drugs or supplements, they target just that, removal of the senescent cells. The second antagonistic reason for aging is mitochondrial dysfunction. Mitochondrial dysfunction is negative per se, but for example, where it concerns reactive oxygen species, ROS, ROS are absolutely necessary signaling molecules. At some point, the oxidative theory of aging was very popular. And it is true that at chronically excessive levels, ROS can overwhelm cells and organelles, and then ROS are likely to cause damage. Reason number 3 in the antagonistic group is dysregulated nutrient sensing. Nutrient sensing is a cell's ability to recognize and respond to fuel molecules such as glucose or fats. We have multiple nutrient sensing pathways that regulate intake to provide just the right amount of nutrition. Some examples of research nutrient sensing pathways include insulin and insulin-like growth factor pathway, mTOR pathway involving sirtuins. And an example of dysregulation, a misguided hypothalamus may signal for nutrient intake when the body actually doesn't need it. Interestingly, so many interrelated pathways link metabolism to aging, that this area, nutrient sensing pathway and their dysregulation, have received probably the most attention in the search for anti-aging interventions. For example, resveratrol and caloric restriction fall into the category of measures that are to counteract dysregulated nutrient sensing. And finally, integrative hallmarks of aging. As I mentioned, they integrate effects of other reasons for aging. The integrative reasons are stem cell exhaustion and altered intercellular communication. Stem cell exhaustion is exactly what it sounds like. But let's take a look at altered intercellular communications as also an example of how reasons for aging are connected, in this case, altered intercellular communications and accumulation of senescent cells. Cells communicate by sending molecular signals. What a cell communicates, what molecules it sends, changes as the cell ages and as we age in general. Aging or senescent cells in an aging person will be sending signals that are geared towards self-preservation of the senescent cells. And those signals are damaging to other cells around them, causing, for example, the state of chronic inflammation. A practical approach to dealing with altered intercellular communications is caloric restriction. Unfortunately, not everything that works in animal models works for humans, and a type of caloric restriction that is the most likely to work for humans is intermittent fasting or periodic longer fasting. So that's the hallmarks of aging from Cell 2013. To make the picture complete, I would like to mention other reasons for aging which are not fully or partially in line with the framework in the hallmarks of aging. Starting with decline in autophagy. I recently saw a paper where decline in autophagy was stated as the 10th hallmark of aging. If you recall the angle from which I was presenting information in this video today, we were talking about the causes and traits of use, and proper levels of autophagy is one of them. So decline in autophagy is the reason and cause of use and health becoming less effective because it's being undermined by causes and traits of aging. Then, also recently, degradation of the extracellular matrix was proposed as the 10th or 11th hallmark of aging. Further, some scientists or medical practitioners would zoom in on such reasons for aging as neuroendocrine theory or the state of chronic inflammation as standalone reasons for aging. In the framework of the hallmarks of aging paper, both fall under the integrative group under the altered intercellular communications. Then, a hypothesis of antagonistic pleiotropy. Antagonistic pleiotropy, as it applies to aging, hypothesizes that we possess genes that enhance fitness early in life but diminish it later in life, and that those genes cause aging to emerge. Finally, there are differences in opinions on the 4 primary reasons. Is there one among them that is the primary? For example, epigenetic program of aging or telomere shortening? As you can now see, the causes of aging and their interplay are substantially more complex than saying something like oxidation, inflammation, and unhealthy lifestyle are causing aging. And this is the end of the theories of aging fun for today. If you encounter an anti-aging product with well-crafted marketing claims, you can now identify which causes of use or causes of aging, if any at all, that product targets. In the next video, we are going to reconcile two opposite points of view on aging and link that into anti-aging measures. See you next time.